Hello, and welcome to the App Inventor Find the Gold app tutorial. Go ahead and download the app listed in the description of this video. Then you can upload it to My Projects by clicking on My Projects in the App Inventor viewer and Import Project from My Computer. You can then upload the file. The App Inventor Find the Gold template should open automatically, and you'll see this screen in front of you. Before you add anything else, go to the Components section, click on the screen, and go to the Properties. Scroll down and make sure that your screen orientation is set to Portrait. This is because we're going to be tilting the app around a lot and tilting the screen, and we don't want it to randomly go into landscape mode when you're just trying to tilt it in portrait mode. This is the template screen. We've already set up the visible components, but it's up to you to do the blocks. The Find the Gold game is a very simple game that consists of tilting the device screen to bring this ball through a maze and to finally reach the gold. The ball here is a ball sprite that is specific to App Inventor and has an X, Y, and Z coordinate. We'll go through that later. The maze is made up of 4 wall sprites, 2 horizontal ones and 2 vertical ones. Sprites are another App Inventor object that's very good at detecting collisions, which we'll need. The pot of gold is also a sprite so that it can detect collisions, but it has the image of a pot of gold on top of it so that you can see that it's the goal. We also have an accelerometer sensor, which senses when you tilt your device so that you can move the ball, and a notifier, which we'll use later. Now, let me give a quick overview of how X and Y coordinates work in App Inventor, and then we'll go into the blocks. The X coordinate is how far horizontally, to the left or right, you might be. The Y component is how far vertically, up and down, you might be. Something that's very important to note is that X and Y will start at 0. They do not go negative. And the 0, 0 point, the very smallest X and Y point, is actually at the upper left-hand corner of the screen. So, if you want to increase X, you'll go from left to right. Your maximum X is at the far right. But if you want to increase Y, you actually go down, because the 0 value of Y is at the top, and so the maximum value of Y is at the bottom. All right, let's start looking at the blocks. As you can see, we have horizontal walls, 2 vertical walls, and a pot of gold sprite. We're going to be setting their positions not by just dragging them in, but actually by setting their X and Y coordinates in the block section. You might be wondering why we're not dragging them in, and this is because every tablet and mobile device has a different shape. If we just drag them in physically, it would get thrown off by different sizes of the tablets, and so it's better to set it mathematically. Let's do that now by going over to the block section. To do that, click the upper right-hand button called Blocks. Here's the very beginning part of the setup maze procedure. This sets the position of all the sprites. As you can see, we've already done some of it for you, namely the gold sprite, the horizontal wall for these 3, and the vertical wall for these 3. We still need to do the second horizontal wall and the second vertical wall. To do this, we're actually going to just duplicate some of these blocks and change them how we need. To duplicate, you can right-click on a block and press duplicate. Let's do horizontal wall 2 first. First, we need to duplicate the set vertical wall 1.x. Right-click and press duplicate. We're going to change vertical wall 1 to horizontal wall 2. But it's going to have the same width, so we don't need to change this. Now, we're going to duplicate set vertical wall 1.y. Duplicate, drag it below, and instead of vertical wall 1, horizontal wall 2. But instead here, we're going to actually change the 0.4 to a 0.5. This will move it down a little bit by increasing the height. Now we need to duplicate the set horizontal wall 1 dot width, because we need to set the width of horizontal wall 2. We duplicate it, drag it in, set it to horizontal wall 2, and we're going to change the width from 0.6 to 0.7 so that it's a little longer. You might be wondering where we got these numbers from. Well, the x position, which you might remember being 0.3, you can see that horizontal wall 2, which is this one, is about a third of the way across. For the y, which was 0.5, you can see that it's about halfway down, which is 0.5 of the height. And for the width, which is going to be the length of this horizontal wall, it was 0.7, and you can see it takes about 7/10 of this horizontal part of the screen. This also makes sense mathematically, because if it's 0.3 across and 0.7 long, that takes up the whole canvas. Now let's do vertical wall 2. We can duplicate vertical wall 1 and just change it a bit. Duplicate this block, change it to vertical wall 2, and change it from 0.3 to 0.7. Now let's do the y component. Duplicate the vertical wall 1 y component, bring it over here. We'll set it to vertical wall 2. Its height is now going to be 0.8. And finally, we need to set its height. Let's duplicate the height of vertical wall 1, drag it in, set it to vertical wall 2, and change its height to 0.3. Now, for vertical wall 2, this one, we set its x component to be 70% of the width, and you can see that it's about 70% of the way from the beginning. Its y component, it's pretty far down, and this is about 80% of the height, which is what we set it to be. And finally, for its height, the actual height of the wall, it's going to be about a third of the height of the canvas. There we go. These are the components that we need. Let's drag them into the setup maze procedure. Let's take a look at the gold sprite. Remember that the gold sprite is at the lower right-hand corner. It says that we set the gold sprite's x position to the canvas width minus 70. So the canvas width is as far to the right as you can. It's the maximum value. And same thing here. We set its height, its y position, to the canvas height minus 70. So the canvas width and height is the lower right-hand corner with the maximum width and the maximum height, right down here. And if we subtract 70 from the width and subtract 70 from the height, here we are, right at the gold sprite. We do similar things for the walls. For example, we'll set the x to 0 and the y to be an actual percentage of the canvas height. So for example, here in this block, the horizontal wall's y coordinate is actually just 20% of the height. You can see that here, that it's actually just 1/5 of the current height. It's not very low down. So we've already set up the setup maze component. You might be wondering what this purple wrapper block is. It's called setup maze. And this type is actually a procedure. Just naming a procedure doesn't do anything on its own. But if you later call the procedure, then you can use this block of code anywhere you want just by saying call setup maze instead of needing to copy and paste these tons of lines of code a bunch of times. So when do we want to set up the maze? Well, we want to set up the maze every time you start up the app. So every time that the screen starts up. We can actually do this by clicking on the Screen 1 block section and check when Screen 1 is initialized. Right here. So when the screen 1 is initialized, we want to do setup maze. This is in procedures because setup maze is a procedure type, and we do call setup maze. And there we go. As soon as we initialize the screen and start up the app, then it'll set up the maze and put all the blocks in their correct locations. Now is a good time to test your app because everybody's device might have a different shape, and so these exact numbers and dimensions might not work for your device. To connect, go ahead to the top bar and click Connect and AI Companion, and use the AI Companion app to connect using your device. If you do need to modify some of the numbers and don't want to reconnect every time to initialize the screen, you can actually just right-click on the Setup Maze and click on Do It, and that will refresh it. Once you're done getting the maze exactly how you want it to be, we can continue. The Do It command is also a pretty good example of how to fix things if your maze doesn't look exactly right. Here, I've intentionally changed some parts of the maze to give an example so that we can fix it together. I'm emulating the build here, but you'll most likely see it on your mobile device. As you can see, the maze doesn't look quite right. Most notably, vertical wall 2, this wall right here, isn't in a right position to make an effective maze. Well, let's think about where this should actually go. First of all, we want it to be a little bit more down. That way it can make a passage this way. And we probably want it more to the right so that it's closer to the pot of gold. Well, to bring it more to the right, we need to change the vertical wall's X position, as you can see here. And to increase it, that will bring it more to the right. So instead of making it 0.5, let's make it 0.7. And to actually see this change reflected, make sure to right-click on Setup Maze and press Do It. See, it moved to the right when we increased its X. This is a little better, but we still definitely want to move it down so that it makes a cooler maze. To move it down, you want to change vertical wall2.y, this block. And to bring it down, we also need to increase its y component. Let's go from 0.5 to 0.8. Again, let's do it for Setup Maze. And there we go. This is a more effective maze. Now you see how Do It and testing things in real time can help you make your own maze. The next part that we need to do is set up the movement for the ball. So the movement for the ball happens every time you tilt your screen around, and so this is related to the accelerometer. Let me show you a quick demo right now of how acceleration works. Okay, let's take a look at how the acceleration works for App Inventor coordinates. Currently, because the tablet is flat on the surface, its x acceleration from left to right is 0, and its y acceleration from top to bottom is also 0. Let's see what happens if we tilt it. If we tilt the top of the screen, you can see that acceleration becomes positive. Conversely, if you tilt the bottom of the screen up, you can see that the y acceleration becomes negative. It's a little bit different for the x and y side, so let's take a look at x now. If you tilt the left side up, you can see that its acceleration becomes negative, and when you tilt the right side up, you can see that its x acceleration becomes positive. The accelerometer component is down here, and we want when the accelerometer sensor senses that the acceleration has been changed. So let's drag that in. When the accelerometer has changed, you want the ball sprite to change its x and y positions to move around the screen. So let's click on the ball, and we need to actually set its x and y coordinates to something different every time you move it. So right down here, you can see that there's set ball1.x and set ball1.y. Let's drag those both in. There we go. And we want it to be dependent on what it was before, the previous ball1.x and .y. So this is going to be some addition and subtraction. To get addition and subtraction, go into the math drawer in blocks and scroll up to the addition and subtraction blocks. For the x, we're going to want a subtraction block, and for the y, we need an addition block. I'll explain the difference between those two later. So we want to set the ball x position to its previous x position minus the acceleration. So to get the previous x position, you can just get it right here, ball1.x. That's its current. And same thing, let's just get the y position as well. Great. And the way to get the acceleration is actually right here. XXL and YXL. If you just hover over this, you can drag the get X acceleration and the get Y acceleration. And this will set the movement of the ball. So why is this X a minus here? Why are we subtracting the acceleration? Well, the way that the App Inventor XY coordinate system is set up, if you tilt your screen to the right, if you tilt it down, the right side down, well, that's actually a negative x acceleration. And so subtracting a negative x acceleration will give you the positive that you want. You don't have to do this for the y because tilting the bottom side of your screen down is positive, and so you're adding a positive and you get a positive change. Feel free to test your app now and make sure that you can roll the ball around by tilting the screen. All right, at this point, you should be able to tilt the tablet around and move the ball. You can note that right now it goes through the walls, and so now we're going to start working on collisions. Now, we need to take care of collisions. As you roll the ball around, it can collide with two different things, either a wall or the gold sprite. If you've collided with a gold sprite, then that's great, you win the game, and you can go back to the beginning and start again. If you collide with a wall, then you haven't won, but you still go back to the beginning and start the maze from the start. To do that, we need to start detecting collisions. Luckily, we have a block set up just for that. If you click on ball 1 and scroll up, you can do when ball 1 collided with. This block will trigger every time the ball connects with another sprite. And the other component here is what the ball has collided with, either a wall or the gold sprite. So let's check if it has collided with the gold sprite. We're going to need an if statement for this. If it connects with the gold sprite, then you win the game. So let's do that. You can find an if statement in the control, right at the very top. We can drag that in. So we want to check if what the ball has collided with is the gold. So we need to check if the other thing that the ball has collided with is equal to the gold. So the equal sign is right here in logic. Make sure that you're clicking on the logic and not the math, because we're not checking for mathematical equality, we're just checking for object equality. So here's the equal sign. Drag that in, and you can see it has two options. So we check if the thing it collided with is equal to the gold sprite. So click on gold sprite, scroll all the way down, and it has just an empty gold sprite block here. So if the thing is collided with, then, well, you won the game. So you don't want to keep rolling around. You want to stop it from moving. And remember, the ball only moves because the accelerometer sensor is on and doing this block. So if we turn the accelerometer sensor off, then it will stop moving. To turn the accelerometer sensor off, let's go in here and set it being enabled to false. That way it is no longer enabled. You can get a false block from logic. That's great. Once it has connected with a gold sprite and won, then it stops moving. But we also want to move it back to the beginning. And remember, we want to move it back to the beginning no matter what it hit. If it hit a wall, it goes back to the beginning, and if it hit the gold, it goes back to the beginning. So we don't need to put this next part in the if statement because we don't care what we hit. So we're going to put it after. So we need to set its position to its original position. And its original position is coordinate x equals 10 and coordinate y also equals 10. So for the ball, you can call ball.moveTo. This will move the ball to the specified x and y coordinates. Its x coordinate is 10 and its y coordinate is also 10. So you can just get the number 10 by going into math and clicking the very first block. You're going to have to change the number 0 to the number 10, and then you can duplicate it by right-clicking and pressing duplicate. And drag that in. And there we go. It should be able to collide with the wall and return to the beginning, and collide with the gold and return to the beginning, but stop moving because we added this extra if statement. Go ahead and try it out, and make sure it works as expected. Alright, now that we've implemented collisions, you should be able to move the ball around, but when it hits a wall, it goes back to the beginning. See? And then, if we get it all the way through the maze to the pot of gold, then the game will end. Let's take a look. And it goes back to the beginning. Since the game is done, you can't move the ball anymore, even if I turn the screen. Alright, if you tested out your app, you might notice that there seems to be something missing. If you finally get to the gold and win, then you're just put at the beginning and you can't play again. So let's add an option for you to play again or quit if you're done. For this, we're going to use the notifier component that I mentioned. A notifier actually offers a pop-up notification in the screen of your app offering options. For here, we're going to have the options to either continue or to quit. So to get the notifier to pop up, go to the notifier drawer and let's offer a choose dialog. It's right here. Call notifier1.show choose dialog. This will have the pop-up. And these are all the different options, and we're going to have it say different messages. So the message can be, you win. The title of the box, which is just at the very top, could say things like game over. We're going to grab another text box from the text drawer, and this is going to be the first option. So you can choose to quit, so let's call that quit. Or you can have it play again, so let's have the text play again. We also don't want the user to be able to just close out this box without making a choice, so let's set cancelable to false instead of true. That way they have to make a choice to go on. Now, where do we put this? We only want this notifier to show up when you've actually collided with the gold and won. So we're going to put this inside the collided box, but also inside the if statement that checks if you really did collect with the gold sprite. And there we go. Now, when you collide with the gold sprite, it will stop the accelerometer and then offer a dialog to either quit or play again. So what happens when you actually pick that option? Well, we're going to need another block. The notifier has a unique block called after choosing. And so after you pick an option here, either quit or play again, it will immediately fire off this block that takes note of the choice that you made. So the value of get choice is going to either be quit or play again, depending on which one you picked. So if you chose to quit, then we want to close the app. And judging by my wording, it seems pretty likely that we're going to want another if statement. So go back to control and pull in the if-then block. So we want to check if the choice that we got was equal to quit. So again, for the equal sign, we want to go to logic and pull out the equals block. And we want to check if the choice was equal to quit. You can copy it from here. Here's quit. So if choice is equal to quit, then we need to just completely end the app, which is close application here in the built-in control block. Great. But what if you didn't want to quit? What if you wanted to play again? Well, if your choice is play again, then you never get into this if statement. It checks if it's equal, it says it's not equal, so this never happens. But we want the ball to be able to start rolling again, right? So we actually need to re-enable the acceleration sensor. So the acceleration sensor is down here. So let's go in there and set it being enabled to true now. Remember how we set it to false? We want to set it back to true so that we can roll the ball again and play again. And there we go. Now, when you win, you should see this notifier dialog. If you press quit, it will completely close the application. But if you press play again, then you'll be able to play again and roll the ball around. Great. And test your app, and if you've made it this far and the notifier part works well, then congratulations. You've completed the base part of the Find the Gold App Inventor tutorial. And this should be the final version of the Find the Gold app. When we move it, again, if you hit a wall, it'll go back to the beginning. And now let's get it all the way to the end. The thing that we've added, of course, is the notifier, which will trigger once we hit the pot of gold. And there we go. You can see that there's the notifier that says game over, you win. And you have the option to quit, which will close the app, or play again. If we press play again, then the ball is re-enabled, and then you can start again. There are many ways for you to expand this app, and I encourage you to think of your own options. But here are some suggestions. You could, for example, add a life counter that every time the ball runs into a wall, then it decreases the number of lives by 1, and if they get down to 0, then they lose. You could also, conversely, add a score counter that increases the score by 1 every time they hit the gold sprite, and see how high they can get. Go ahead and see if you can add your own experimentations and options. Good luck!